Greetings to all of you. The session is regarding the chemistry on the intermediate floor, which will be fetching for your international entrance and competitive exams. India is conducting JEE Advanced, JEE Mains examination twice a year. That is the entrance or admission for IIT and NIT stream. That is the technical domain. NEET chemistry will be conducted for medical entrance examination, right? So that will be across India. Exam will be conducted for medical stream, and Telangana, Andhra Pradesh government are conducting MCET examination. This will be giving way to admission for BTech stream. Again, it is the technical domain. In addition, government organizations are conducting various job opportunities called competitive exams. Government job opportunities where different kind of subjects will be given for the examination. Among all, general studies is the common question paper which will be applied for all the aspirants. In that, general science content will be there. That general science is required to be answered, so the session what we are conducting is helpful for that kind of preparation. Let's go with the first question. The Nobel Prize in Chemistry 2019 was awarded jointly to John B. Goodenough, M. Stanley Whittingham, and Akira Yoshino for the development of lithium-ion batteries. In the year 2019, Nobel Prize in the Chemistry is accorded for three scientists together. Let me repeat: John B. Goodenough and Stanley Whittingham, Akira Yoshino. So these three scientists together accorded with the Nobel Prize. This is the esteemed and prestigious Nobel Prize in the field of rechargeable batteries called lithium-ion batteries. These are the three scientists who are together accorded with the Nobel Prize: John B. Goodenough and Stanley Whittingham, Akira Yoshino. 1/3 contribution of this esteemed prize is accorded for these three scientists together. And this is about the brief discussion intro regarding the all three scientists who made the outstanding contribution for the invention of lithium-ion batteries and their exploration. John B. Goodenough belongs to the University of Texas at Austin, United States of America. M. Stanley Whittingham belongs to Bing Mountain University, State University of New York, USA. Akira Yoshino is the scientist who belongs to Asahi Kasei Corporation, Tokyo, Japan. Maizu University, Nagoya, Japan. So these are the three scientists who worked on the exploration of, for the development and exploration of lithium-ion batteries, which are most prominent rechargeable batteries. They created our rechargeable battery world. Okay, let's discuss about how the rechargeable battery world has introduced, and nowadays we are most familiar with the rechargeable batteries in the field of automobiles, in the field of industries, in the field of mobile phones. Our mobile phone is recharged for several times so that we can conveniently use this. Lithium-ion battery is most conveniently used in the mobile phone. So that electronic gadget is made up of lithium-ion battery only. So that this is paving the great way for the application that belongs to rechargeable battery world. The Nobel Prize in the Chemistry 2019 rewarded to development of lithium-ion battery. This lightweight, rechargeable, powerful battery is now used everything from the mobile phones to laptops, electric vehicles. Everywhere the application is more prominent. It can also store significant amount of energy, not only for that supplying the battery, supplying the energy, but also that able to store the energy in the larger extent. That is called capacitance. High efficiency energy storage is accorded for these rechargeable batteries and making possible fossil fuel free society, right? So this is the way Nobel Prize in the Chemistry 2019 rechargeable battery, that is more efficient lithium-ion battery, was accorded. Lithium-ion batteries are used globally to power portable electronics. We use to communicate, work, study, listen music, search for knowledge. Everywhere the kind of devices, if you go with the laptop, if you go with the mobile phone, desktop, wherever, so many kind of multi-dimensional applications you can avail by means of these electronic gadgets, which are equipped by lithium ion battery as the energy source. Lithium ion battery have also enabled development of long range electrical cars and the storage of energy from renewable sources such as solar and wind power, right? So they can be recharged by means of either solar energy or else wind power. Such kind of renewable energy is also taken into the consideration, and they find even applications in the electrical cars as well, right? So this is the way lithium ion batteries are most prominent in the field of application of electronic gadgets. Foundation of lithium ion battery was laid during the oil crisis in the year 1970s. Stanley Whittingham worked on the development of method that could lead to the fossil free energy technology. He started the research on superconducting materials, extremely energy rich materials. Superconductors are having 100% proficiency in the passage of current without any wastage. That's why he worked upon that, which is used to create the innovative cathode in the lithium battery. Whenever he is searching for that superconducting materials, he got the idea about this lithium battery. This was made from the titanium disulfide, which as a molecular level has species that can house intercalate lithium ions, right? So lithium titanium sorry this was made from the titanium disulfide was taken in that wherever small gaps are present, in those gaps lithium ion was intercalated. This is a kind of mixing of both the components alternative manner. So that kind of intercalated substance got generated by means of titanium disulfide, and in between the spaces lithium ions got embedded. The battery's anode was partially made from the metallic lithium as a strong drive release electrons. So metallic lithium was taken as a anodic compartment where lithium having high susceptibility to release the electrons with the greater ease, so that high electrode potential is accorded for its oxidation process. This resulted in the battery that literally had a great potential just over the 2 volts. So extremely larger extent of voltage will be generated by tiny metal, that is lithium metal. However, metallic lithium is reactive and battery was too expensive to viable. So only the speculation they faced is it is so expensive so that it is not affordable in order to synthesize, in order to manufacture in the what viable way. So that is not affordable, right? So because of its expensive as well as explosive nature, right? So that is also explosive, so that it is not that safe to handle in the laboratory and even for the battery manufacturing. So that are the that kind of threats that they faced whenever they worked upon lithium batteries initially. John Goodenough predicted that a cathode would have even greater potential made using metal oxide instead of metal sulfide. He replaced metal sulfide with metal oxide so that the efficiency got increased many folds. That kind of a morphalization got carried by John Goodenough. After a systematic research in the year 1980 demonstrated that cobalt oxide with intercalated lithium ions can produce much as 4 volts. Okay, whenever they are going to blend both the materials together, one is about cobalt oxide and either is about lithium ions. Whenever these are used to be taken as a composition for the cathodic compartment, so that their initially 2 volts of current they manufacture, whenever they morpholize the entire composition of this kind of battery, so it was raised to the 4 volts high efficiency battery got manufactured. It was important breakthrough and would lead to the much more powerful batteries. So being 4 volts of current by the single entity of galvanic cell is not that simple, and it is said to be a more powerful battery in the entire history, right? With a good enough cathode as a basis, Akira Yoshimo created first commercially viable lithium ion battery. So initially the way was introduced by the Whittingham, and the kind of efficiency got enhanced or elevated by John Goodenough, and scalable way of lithium ion batteries were synthesized by Akira Yoshimo in the year 1985. Rather than using the reactive lithium in the anode, he used a petroleum coke, carbon material that, like to the cathode cobalt oxide, can intercalate lithium ions. This is the way the three scientists together worked on the lithium ion battery so that the efficiency of these batteries are enhanced. Nowadays, it is the common battery everywhere. You can find a lithium ion battery everywhere. Wherever electron gadgets you observe, there the lithium ion batteries are more prominent. Nowadays, mobile phone utilization is more essential. It is the more essential gadget, we can say, wonder advent of the 21st century, we can, sorry, 20th century, we can say. That is a mobile phone which is equipped by, which is energized by this lithium ion battery only, right? So this is the way the outstanding contribution, more usable quality of the batteries were manufactured by these three scientists together, so that 2019 Nobel Prize was accorded in the field of chemistry for the invention and development of lithium ion batteries. Okay, move on to another question. This was taken from the Cambridge Assessment International Education. Here anion and it's a test, and what test results we are getting, these are performed in a series of reactions. So this is the kind of information rather than a single question, we can say. So here commonly available anions in the entire field of salt analysis are taken as a carbonate, chloride, bromide, iodide, nitrate, sulfate, and sulfite. These ions, if present in the given salts, how can we identify? How can we analyze? This is a kind of a qualitative analysis, we can say. A known compound was taken if it contains bicarbonate, and the test was conducted by the addition of few drops of dilute acid, and whenever acid is added, so that effervescence you can notice. Effervescence means the bubbles of gases are noticed on the top of the region. Those effervescence because of the generation of carbon dioxide. Being carbonate is able to release the carbon dioxide which used to produce the effervescence over there, so that you can identify the given anion must be carbonate, because effervescence of carbon dioxide responsible for the presence of carbonate whenever treated with acid that used to convert it to carbon dioxide. Move on to test for chloride. Chloride test is most simple and most convenient to handle in the laboratory. So first of all, whatever unknown solution you have, add a few drops of acid for that, and dilute nitric acid will be added. So in order to acidify, we need to add dilute nitric acid solution whenever nitric acid is added, so that the entire medium is become acidic. Then a few drops of aqueous silver nitrate solution is added. Whenever silver nitrate is added, chloride will be precipitated into silver chloride. That silver chloride precipitate exhibit white color precipitate, so that white color precipitate appearance indicates that solution is having chloride ion in that as a anion. And in order to identify bromide composition in the given unknown solution, first of all, unknown solution to be acidified by means of nitric acid, few drops of nitric acid will be added into the test tube by means of the dropper. Then aqueous silver nitrate again, so whatever halide is there, the common test you can perform is silver nitrate test, but the color of precipitate is different. If silver nitrate is added to the bromide, so that cream color precipitate is obtained. This cream color precipitate indicates what the formed product is silver bromide, and existing of anion, the conformed as a bromide will give the cream color precipitate in the test tube whenever silver nitrate solution was added. Okay, iodide can be identified by taking unknown solution containing iodide and a few drops of acid, that is again nitric acid will be added, and again testing reagent is the silver nitrate. Whenever silver nitrate few drops added, immediately yellow color precipitate is separated out. Presence of yellow color precipitate indicates the given unknown neon is iodide, and here the reagent silver nitrate is suitable to find out. In order to trace out nitrate ions in the given unknown solution was taken into the test tube small quantity, and the sodium hydroxide. Here again we are making the solution basic. Earlier we made with the acidic solutions. Here the nitrate test is accompanied by the sodium hydroxide, addition of sodium hydroxide followed by Aluminium foil will be inserted, and after inserting aluminium foil, you have to go for the heating for short while. Very careful heating is required over, otherwise bumping of solution may takes place. In order to avoid, you have to go for safe handling of chemicals by mild conditions, right? Nitrate will be identified as the gas is coming out. If you smell it, so you can observe that ammonia gas pungent smell you can notice over there, so that you can identify presence of ammonia. Or else you can go with the litmus test. So red litmus, if placed upon the effervescence of ammonia, so that it will turn into a blue in color. This indicates what the ammonia gas is coming out, and subsequently the test is positive for nitrate ions. In order to confirm the presence of sulfate ions by qualitative analysis, take the unknown solution containing sulfate, and dilute nitric acid is used again for acidification process. After the acidification, aqueous barium nitrate solution will be added. Few drops of barium nitrate if added, this entire sulfate will turn into a white color precipitate form. White precipitate indicates the presence of sulfate ions. This is the confirmation test for sulfate. Move on to sulfite. Short of one oxygen is called sulfite, and again the sulfate ion, we have to go for acidification of the solution. Acidification, after getting the acidification, the test reagent is potassium manganate. Potassium manganate, when added, the aqueous potassium manganate solution color initially purple, and after the addition of sulfite ions, that is turning into a colorless solution. This is the way you can go for the confirmation for sulfite. So individual tests are provided with a greater explanation for your convenience. If carbonate is present, I am taking copper carbonate for your kind reference, and this copper carbonate can be treated with any acidifying agent. I am taking hydrochloric acid. Whenever hydrochloric acid is adding, that copper is converted into copper chloride and releasing carbon dioxide as a gaseous substance. This carbon dioxide released can be observed as a effervescence. You can clearly understand these effervescence belongs to carbon dioxide. Okay, and next is about if magnesium carbonate present sulfuric acid when treated, again you can notice whatever carbonate is there under acidic condition that used to release the carbon dioxide, that is a common thing you can notice over there. Later on, you can move on to presence of chloride. In order to identify the chloride, first dilute nitric acid will be added. A few drops of silver nitrate when added, you can notice the white color, milky white color precipitate of silver chloride will be formed at the bottom. This indicates presence of chloride ions. This is the common test for chloride. Silver nitrate is available. Silver nitrate test is available for all the kind of halides you can observe. If silver nitrate test for bromide, you can observe the cream color precipitate. Presence of cream color precipitate indicates the presence of bromide ions. Silver nitrate test, if it is generating yellow color precipitate, you can identify the given ion is the iodide, right? And move on to nitrate confirmation. For the nitrate, you can add the sodium hydroxide slightly, and whenever sodium hydroxide is added, sodium nitrate will be formed. Aluminium foil is inserted, and the better reducing agent, so that it used to reduce the sodium nitrate. Whatever oxide form of nitrogen is there, that turned into ammonium form, that means hydrate form. So this is a kind of reduction process. Upon reduction, you can observe ammonium ion. Upon treating with the sodium hydroxide, so that ammonium ion will be turned into ammonia gas. The presence of ammonia gas can be identified by litmus test. Red litmus turned into blue color indicates the presence of ammonia gas, so that nitrate will be confirmed. So barium test, test for sulfate. Whenever sulfate ions present, barium nitrate if added, you can notice the white color precipitate. Due to the formation of barium sulfate, this white precipitate indicates the given anion is the sulfate, because barium sulfate is the white color precipitate. This is the way you can observe the presence of sulfate ions. And test for sulfide. Sulfide can be tested with the permanganate. When permanganate, acidified permanganate is added to this sulfide ion, that used to give sulfide will be converted into sulfate form over here, and manganese purple color will be disappeared and colorless solution you can notice. Decoloration of the purple color is the indication for this sulfite ion. Being caminophore is the oxidizing agent, SO3 is turning into a SO4. That means oxidation process got carried over. This is the way entire series of identification of anions we can notice. This is the most valuable analytical data for the qualitative analysis, qualitative identification of anions. Move on to another question, which is question number 3. Question number 3 collected from 2017 paper 2 question, and it is most important given from the organic chemistry point of view. For the following compounds, the correct statements with respect to the nucleophilic substitution reactions are. So all these substances are participating in the nucleophilic substitution. Regarding nucleophilic substitution, what are the true statements we have to identify? 1 and 3 follow SN1 mechanism. First compound is called benzyl bromide. Third compound is called butyl bromide. For SN1 mechanism, the most required thing is tertiary carbocation. So that obviously third compound will participate in the SN1 mechanism. First compound is CH2. So here you can notice sp3 carbon is there. sp3 carbon most obviously go for the SN1 reaction, and moreover whatever bromo removed, so that you will get carbocation over here. Generated carbocation is more suitable for the resonance stabilization, because benzyl carbocation is 100% resonance stabilized, so that more stable benzyl carbocation is the intermediate, so more prone for SN1 mechanism. So that 1 and 3 obviously go for SN1 mechanism, that is true. 1 and 2 follow SN2 as well, right? This is also possible because second compound if you observe and first compound if you observe, so here the carbon is having CH2, two hydrogens are present on the carbon, so that SN2 mechanism is a concerted kind, that will not go for the multi-step process, rather you can simultaneously remove the existing nucleophile and simultaneously new nucleophile is coming from the back end. So this is the reason why here CH2, being it is not the bulky one, it is more convenient for SN1 and SN2 as well. So that SN2 is also possible in compound number 1. And obviously compound number 2 you can notice this carbon is having two hydrogens, being it is not a bulky one, so that another nucleophile conveniently comes and simultaneous removal of bromide is possible, and 1 and 2 are more susceptible for SN2 mechanism. This is 1 degree, this is 1 degree, we can say 1 degree alkyl halides are more susceptible for SN2 mechanism, so that 1 and 2 are going towards SN2 mechanism of nucleophilic substitution. Compound 4 undergo inversion of the configuration. Inversion is possible for what? SN1 or SN2? SN1 gives mixture of two products, 50% dextro and 50% levo is possible. If you go with the bimolecular nucleophilic substitution called SN2 mechanism, SN2 mechanism providing inversion of the configuration. If you are having R configuration after the product formation, that will be shifted to S configuration. So that inversion, completely reverse, that is noticed in compound number 4, because it is more susceptible for SN2 mechanism. You can notice here is the carbon with the hydrogen atom, so it is the 2 degree carbon having alkyl group, so that 2 degree alkyl halide are suitable for what? SN2 mechanism. So you can put a tick mark over here. The order of reactivity 1, 3 and 4 is highest, 1 is next, and 3 is least. That is because whenever you go with this one, let me explain about the reactivity purely laying on the stability of intermediate formed. Whenever bromo group is removed, for example, the formed carbocation is more stabilized over here in comparison to all the remaining. The reason behind is the carbocation is in conjugation with these 3 pi bonds which are in conjugation, so that this is the kind of resonance stabilization. And one more mechanism also plays additionally, that is hyperconjugation. This methyl is having 3 alpha hydrogens which are ready for the alpha hydrogen donation towards this carbocation is formed. That's the reason why two operations are increasing the stability in multi-dimensional way. So fourth compound is more suitable for the substitution first. On the next level is given for this benzyl bromide, where benzyl carbocation resonance stabilized again. And this carbocation, this is called aliphatic carbocation, stability purely relying on the hyperconjugation itself. Here resonance plus hyperconjugation higher, and only resonance is the second level, only hyperconjugation is the third level. This is the way you can notice the stability of carbocation and subsequently rate of reaction towards the substitution, so that the correct order will be fourth is highest, followed by 1, followed by 3 is the correct one. Let's go with the detailed explanation regarding this. In case of first one, A option, 1 and 3 follow SN1 mechanism. Benzylic and 3-degree halides SN1 mechanism is possible. This is called benzylic bromide. This is called a tertiary butyl bromide, which is a 3-degree alkyl halide. Both are more suitable for SN1 mechanism because SN1 that is multi-step. Formation of carbocation followed by carbocation will be added with the nucleophile, so that these two are giving more stable carbocations. That's fine. Benzylic and primary alkyl halides both follow SN2 mechanism. So even benzylic bromide is of least 1-degree alkyl halide, so that there is a possibility of SN2 as well. SN1 is possible, SN2 also possible for this one, and the second one is also 1 degree, so that it will participate in a SN2 mechanism. That is correct. Benzylic 2-degree alkyl halide can undergo inversion of the configuration. This is called a 2-degree carbocation because one of the hydrogen is there and two alkyl groups are accompanied, so that this is 2-degree. 2-degree alkyl halide is more suitable for SN2. Subsequently, inversion of configuration is followed. The order of reactivity for SN1 and SN2, if we are not categorizing, this is SN1 reactivity, this is SN2. Both together, either SN1, it might be SN2, whatever, but the cumulative reactivity is 4 is highest, later on 1, later is 3 is the correct answer. That we explained based on the intermediate stability during the reaction proceeding. Okay, so this is the way we can answer question number 3. All 4 options are correct. This is SN1 mechanism. You can notice carbocation is formed in the step number 1 and step number 2, faster reaction to occupy the nucleophile over here. And SN2 mechanism, there is a kind of subsequent removal of the existing nucleophile and the addition of new nucleophile from the back end, so that we will get inversion of the configuration. From the back end, the reagent will be added. That is clearly mentioned in this video clip. SN2 reaction mechanism. Move on to question number 4. Among the following correct statements are trimethyl aluminium has the 3-centered 2-electron bonds in its dimeric structure. Whenever trimethyl aluminium is forming a dimer, so that there is a formation of 3-centered 2-electron bonds are possible. Boron trihydride has the 3-centered 2-electron bonds in its dimeric structure. Here also 3-centered 2-electron bonds are available, they are saying. Aluminium trichloride has the 3-centered 2-electron bonds in its dimeric structure. AlCl3 has 3-centered 2-electron bonds. So AlCl3 is not having 2-centered, though it is possible to get the dimeric structure, but it is not the 2-centered 3-centered 2-electron bond. It is the kind of 3-centered 4-electron bond only, right? Lewis acidity of boron trichloride is greater than that of aluminium trichloride. This is also correct one. Except option C, A, B and D all are correct. So let's see how can we explain this one. A, B, D are correct. AlCH3 taken thrice and BH3 has 3-centered 2-electron bonds in the dimeric structure. Here, the dimeric structure, if you observe, if you see this 3 bonds, aluminium is 1 atom, CH3 is another atom, aluminum is another atom. How many atoms you can notice? 1, 2, 3. So that we can say 3 centers are there. 1 aluminium, 1 methyl, 1 aluminium. 3 centers are there. Among 3 centers, if you observe the bonds, this is 1 bond, this is 1 bond. But one bond is not contributing two electrons, so that four electrons are present. That is not the case. Here, two electrons sometimes laying in between aluminium methyl, sometimes they are laying in between aluminium methyl this side, so that three bonded atoms are present, but bonded electrons are only two, right? So two electrons are sharing sometimes over here, sometimes over here. That is the reason why it existing in the dimeric form. This is called what? Three center to electron bond. This is the one kind of three center to electron bond, and another side also you can notice aluminium CH3 aluminium. Here also you can notice three centered to electron bond. So the total possible three center to electron bonds are two. This side one, this side one. So this is one of the option we noticed in the option A. Three centered to electron bonds are present in the dimeric form, we noticed just now. In the same manner, BH3 is also having dimeric form, which is called B2H6 diborane, we can say. The diborane is also, you can notice boron, hydrogen, boron, three centers are there, and these electrons are sharing up sometimes over here, sometimes over here, so the two electron bonds are present. This side one, two, three center to electron bond, this side another three center to electron bond, you can notice. So that two three center to electron bonds are possible for BH3 molecule or B2H6 dimer. Move on to AlCl3. AlCl3 dimerized in this manner. Whenever AlCl3 is dimerized, all the bonds are having two electrons. So that bridged chlorides not having three centered two electron, rather three centered four electron bonds are present. This is not that electron deficient. Coordinate bonds are possible, so that option C is striked off. Move on to option D. The Lewis acidity of BCl3 is greater than that of AlCl3. Why BCl3 is more acidic than LCl3? BCl3 is more Lewis acid because it involves the overlap of 2p orbitals, which is more stronger than 3p orbitals. 2s and 2p orbital overlap is much stronger in case of boron atom in comparison to the 3s and 3p orbital overlap of AlCl3, because in comparison to the 2s 2p, 3s 3p is somewhat outer orbitals are not having that extent of attractive forces. 2s and 2p are having extent of attractive forces larger, so that BCl3 is said to be stronger Lewis acid in comparison to AlCl3. That is purely because of overlapping of 2s and 2p orbitals, and stronger 2s and 2p orbital overlap in comparison to 3s and 3p orbital overlap. This is the way we can answer. So correct D is also correct one. The correct options for option question number 4 will be A, B, and D. C is incorrect. Move on to question number 5. Question number 5, which of the following has the largest de Broglie wavelength? De Broglie wavelength to be calculated for all these four questions. A bullet of mass 0.02 kilogram moving with the speed of 1 kilometer per second. A ball of mass 0.06 kilograms moving with the speed of 10 meters per second. A particle of mass 0.01 kilometers moving with the speed of 100 meters per second. A ball of the mass 0.03 into kilograms moving with the speed of 1 meter per second. So if this is the case, what you can observe, the formula we are using for this de Broglie equation will be, de Broglie wavelength is given by the equation lambda is equal to h m nu. H by m nu. H by m nu. H is called Planck's constant, m is called mass of that one, and nu is called, v is called what? Velocity, right? The particle which is moving with the velocity, that speed was taken into the consideration. Okay, so for this, right? So here the de Broglie wavelength based question was given, and here mass and the speed of the atoms are provided. Two parameters are mentioned with you. By using these two parameters, you have to go for de Broglie wavelength calculation. De Broglie wavelength calculation equation is given by lambda is equal to h by mv. H is called Planck's constant, m is called mass of that atom, and v is called velocity. right? So always lambda is inversely proportional to its mass. Greater the mass, lesser will be the wavelength of that particular particle. Okay, so in that context we will go with the all four options. We have to calculate the wavelength for individual terminology. So that let's apply the formula h lambda is equal to h by mv for a bullet. Lambda bullet is equal to h Planck constant value is 6.626 into 10 to the power negative 34. And here in the option number 1 they mentioned 0.02 kilograms. That 0.02 kilograms were taken and the speed is given as 1 kilometer per second. So kilometer can be converted into meters, so that it is converted like this. So here after the entire calculation we will get a 0.33 into 10 to the power negative 34. This is for what? Bullet. And the same can be applied, same formula, de Broglie wavelength formula, lambda is equal to h by mv can be applied for a ball. 6.626 into 10 to the power negative 34 by its weight is given as 0.06 kilograms and speed is 10 meters. And let's put 0.06 and 10 meters over denominator terminology, so that the entire calculation you can notice 10.04 into 10 to the power minus 34 is the wavelength. And move on to this, the particle. For this particle, that weight is given as 0.01 kilograms and speed is given as 100 meters, so that you can put all the terms over there. Planck constant will not be changed for any problem, so that you can put a constant value. And if you go for the calculation, the value is 6.62 into 10 to the power negative 34. And move on to last one. Again, it is a ball and weight 0.03, speed is 1 meter per second. So in that context, you can go for h value 6.626 into 10 to the power minus 34. Mass is given as 0.03 and here velocity is 1 meter per second, right? So denominator terminology is very small in comparison to all the remaining, so that the larger lambda value you can notice. Among all this, the largest wavelength is noticed for this ball, that is given in the option number 4. A ball of mass 0.03 kilograms moving at the speed of 1 meter per second is having the largest de Broglie wavelength. After the calculation, you can go for the comparison of the numerals. So by this, you can achieve the answer for question number 5 as the answer number 4. Move on to last question of the session. It is again collected from Telangana IMSA 2022 question paper. The maximum number of orbitals present in N is equal to 4 energy level of the atom. Maximum number of electrons with the spin value plus half in the same orbitals are respectively. Here, single question is having two options, two answers to be mentioned over there. Number of orbitals required, number of electrons with the plus half spin also required. This question is given from atomic structure. In specific quantum numbers based question it will be. The requisite answer is 16 number of orbitals, 16 electrons with the plus half spin. How can we answer? We can see. Okay, they mentioned the principal quantum number value. N is equal to 4 is nothing but N is nothing but principal quantum number whose value is 4. Okay, so in case of N is equal to 4, the probable orbitals are 4s, 4p, 4d and 4f. S orbital, everybody aware S orbital is spherical and only one orbital you can notice. P orbital is the dumbbell one and 3 p orbitals will be present. Everybody know about this one. P orbitals are 3. Always d orbitals are 5. dxy, dyz, dzx, dx square minus y square, dz square. These are the orbitals of 4d. And 4f orbitals are 7. Everybody know about this term. F orbitals are 7, d orbitals are 5, p orbitals are 3, s orbital is only 1. So 4s 1, 4p 3, 4d 5, 4f 7. If you go for the addition of all these, so that 16 orbitals we got. Or else you can use the simplest empirical formula in square. Right, N is known to you, N is the principal quantum number 4. So that put the 4 square over here. 4 4s are 16. 16 is the total number of orbitals. Whatever quantum number, whatever principal quantum number you know, so that just apply the formula in square over there, so that you can minimize your problem solving time. Okay, so this is the way 16 orbitals we got. Okay. So after getting 16 orbitals are having, so if 16 orbitals are present, each orbital having the maximum occupation level will be 2 electrons. One orbital, 2 electrons is the maximum limit. So each orbital can accommodate 2 electrons. So that 16 orbitals able to accommodate 32 electrons. Among 32 electrons, 16 electrons are spinning with the clockwise spin. Another 16 electrons are spinning with the anti-clockwise spin. So that the required answer is 16 electrons are spinning with the plus half spin. That means clockwise is designated as the plus half spin. That is mentioned in option number 4. For n is equal to 4, the number of possible orbitals are 16, and the place of containing number of orbitals also 16. This is the way we can answer the question. So by this, we entirely completed the session, and this is more informative and more problematic part, mechanism, reaction mechanism part, and atomic structure. So many concepts are taken into the consideration for your valuable, to minimize your valuable preparation time, so that whoever continuously following the kind of series of sessions whatever we are creating, this is 100% suitable for your entrance exam or else any competitive exam you are seriously aspiring for. So the session will give the real information and authentic information which is collected from the more reputed websites. And moreover, so many times repeated questions are taken into the consideration, so that I will assure for the 100% what success in your exam what you're aspiring for. So that I'm sincerely requesting to like the channel, comment. So in order to comment, we have a question over there. In order to go for the quantum numbers, you can put the list of quantum numbers, how many quantum numbers we have, what are the names of those quantum numbers, can be commented in the comment box for the session, right? So for this video, for this session, you can answer number of quantum numbers which are available and the name of those quantum numbers which are present in the entire what atomic structures, that you can comment and share with these parents who are more curious about the examinations and knowing of the knowledge about chemistry. Definitely, if you are watching continuously the kind of sessions what we are creating, you can improve your zeal for the chemistry, right? Subscribe the channel to receive more updates in the near future. We will definitely go for the new content in the near future, and the valuable information will given to your knowledge thirst, right? So thank you for watching. Thank you one and all.